Johnny, you're stuck in a whirlpool. Give me a number. Make it a small number. 4? Okay. Now you get to choose either counterclockwise or clockwise. Okay, so you're choosing counterclockwise with 4. Next, Jane, it's your turn. 3, okay. And you can see, so now I'm going to step back from this. The way that I approach describing puzzles is to come into the classroom, and it's no explaining the rules. You still don't have any idea what the rules are for this puzzle. Instead, you're trying to engage the students quickly, efficiently, and you do that by addressing them one at a time. So different students get to choose each of these arrows and which number is on them. After 1 minute, you have a loop like this, and then you say, okay, so where are we going to start? Well, let's start at this number 4. Again, you have a student choosing randomly. And how many spaces do we count? We count 4 spaces. So we're in this whirlpool, and you're going to be counting 4 spaces. 1, 2, 3, 4. We're going to end up over there. Now we count 1 space. That's right. And what do you think we do now, Emily? We count 2 spaces. And again, we are going in a counterclockwise direction. The kids don't know what counterclockwise and clockwise means. This is a grade 1 class. But you just use the terms, and let's see, where does 2 get us? 2 gets us right here. They can be standing up. You can invite them to the front of the room. You can instead just leave them where they're seated. What you don't do is you don't have children raise their hands and says, I know where it goes. I know where the number 1 goes. It goes to up to the number 2. You don't have kids raise their hands like that. Instead, you're in control. You say, Stephen, it's your turn. Where does that one go? Okay, it goes to the number 2. Okay, number 2 goes to the number 5. That's right. And Jane, where does the number 5 go? And she says number 4. No, Jane. Oh, yeah, no, you're right. You're right. Making little mistakes like that in a grade 1 class makes sure that the kids know that you're not a goddess or a god standing on high with the answer, but rather that you're struggling with them. So little mistakes made on purpose, whenever she says the number 5 goes to the number 4, you say, no, no, you're actually right. So just a little technique to play with. So now I'm at that number 4. You can, move a little. If this is on a whiteboard, you could just keep your finger on it, or you could move around, or you could have a child actually hold their hand on where they are right now, being sucked into this whirlpool. Okay, so number 4, where do we go now? Oh, we're going back to a place that we've visited before. That's interesting. And again, we end up with this loop. And the kids love if you pretend like you don't realize that you're in a loop, but you just keep on going. Okay, Stephen, where do we go now? 4, 2, 5, 4, 1, 2, 5, 4, 1, 2, 5, 4, 1, 2, 5, 4, 1, 2, 5, 4, 1, 2, 5. Grade 1 kids love this repetition. They love if they realize that you're repeating before you seem to realize that you're repeating. So you can still say, yeah, this is an exciting puzzle, right? Exciting, you're going down a whirlpool. And oh, it's actually boring. You're just keeping on going round and round and round and round. They love this repetition. It's a source of comedy. It also allows slower students to catch up before you seem to realize that, oh, we're going in a loop. Okay, so indeed, that is the end loop. And you know what? We can start from a different place. So, natural question. You should be modeling questions for the students to ask. They might not ask them themselves, but you should say, oh, I wonder if we always end up in a loop of some kind. So we might try starting at 3. Let's see what happens. Well, 3 goes here and then goes over here. And, oh, not only is it a loop, it's the exact same loop. Who would have expected that? Okay. In fact, no matter where you start, with these numbers that the kids have randomly chosen, you end up in this loop. It could be different if children chose differently. For example, and you should ask questions like, or give this as a question to the class. Okay, what happens to this? This is a really hard problem. Okay, Caitlin, what happens here? And Caitlin says, well, you start off with 1, and then you go there, and then you go there, and then you go there. And you keep on going, and you keep on going. And again, you are a little bit slower than your class. Pretend, if you are slow, that's all the better. Okay? But you're pretending with your class. And okay, this is just one giant loop. Let's color that all the same color because we're going in one giant loop. Okay, now let's look at this one. So, 17 seconds quiet. Silence is so underestimated in classrooms. I close my eyes as a signal for children to calm down and to focus on the board. Or I look at the board. Instead of at the children, I look at the board and try to figure it out for myself. 17 seconds of silence. Okay, Jake, where do you want to start? Okay, Jake is going to maybe start at the number 1 and then you can figure out what happens. There's actually 2 different loops here. There's this little one that just goes beep, 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 beep. Use sound effects. Sound effects are great. And then you've got this longer loop, the 4, 1, 5, 4, 1, 5, 4, 1, 5, and then 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. Great for the grade 1 classroom. So, what are some questions? I want you guys now to think of some questions. You should be curious, and you should try to inculcate that curiousness. Try to get your kids to think in a curious way. What questions would you like to answer? What questions would you like to ask? What about using ones? What happens if you just use ones, but you change the direction? What happens here? So the answer is that in this case, we don't end up with one giant loop. We end up with these little pockets of 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then an orange 1, 1, 1, 1, 1. What happens if you start with 2s going round in a giant loop? Again, 17 seconds quiet. If, for example, you asked a child, let's say, Desdemona, what is this? What's going on here? If you look at Desdemona, you can intimidate her. And that should not be your objective. If I stare at Desdemona and I'm looking at her and, she feels pressure. But instead, to decrease stress on students, you say, Desdemona, what's going on here? Okay. And then you focus your attention on the puzzle as if you have not solved it. Okay. Desdemona is still struggling. Then you go back to her and say, so what do you think, Desdemona? Okay, where would you like to start? So if she's still struggling, then you can say, okay, where would you like to start? Okay, Desdemona chooses the top one, and then you just solve that little bit. So removing stress, making kids feel like they can provide hypotheses. I think I know what's going to happen. Opening that up and saying, okay, now I just want hypotheses. What do you think? Again, asking specific students. So Desdemona, what do you think is going to happen if I have 3s or 4s or 5s going around in this circle? What's going to happen? Well, in the case of this 2, here's a solution. There's actually 2 different loops, not one giant one like we saw with the 1s. I hope those little vignettes, ideas that you can use are helpful. The most important thing to realize is that teaching is an experimental art. You shouldn't take my ideas as the absolute truth. You should instead experiment with them, see what works. If it works, keep it. If it doesn't, throw it out. Often you're going to want to connect to a curriculum. You should be thinking more and more in terms of using a sledgehammer. Don't be nitpicking your way through the curriculum. Instead, take a really good puzzle, and that puzzle is going to destroy whole parts of the curriculum. So in this case, you could say that these 10 in a circle, those 10 kind of look like they're giving ideas of clockwise and counterclockwise. So telling time that could be connected to that part of the curriculum in Common Core. It can also be looking at base 10, because you could say, well, I wonder what happens if I put 15 in one of those arrows. Oh, 15. It's really just the same as 5, whether I start here and go halfway around or go 15. 5 and 15 are the exact same. So there's something special about the number 10. Math Pickle and the Julia Robinson Math Festival, these are two places that you can go and get awesome puzzles and problems for your classroom. Enjoy.